Students, if you are going for any competitive exams or say the school board exams, okay, you should always practice this question. This particular question is question number 18 of miscellaneous NCERT. The question is a combination of two different functions. Number one is a signum function, which we have learned in class 11, and the other one is greatest integer function. I'm going to teach you first the behavior of the signum function and the greatest integer function, and afterwards I'm going to teach you or I am going to make you understand that does FOG and GOF coincide in 0 to 1. We will find FOG, we will find GOF, and we will check whether they coincide in 0 to 1 or not. First of all, let us talk about the signum function. This signum function, SIGNUM, signum function, FUNCTN, signum function, it has got a unique behavior. Any value which is less than 0 will be minus 1, equal to 0 will be given 0, and greater than 0 will be 1. That means its domain is R and the range is minus 1, 0, 1. The graph of this signum function you can draw like this. This is a real line. Okay. And what we do is, suppose for 0, we get 0. Okay. Signum function, you can think of x by mod x. Okay. This is signum function, or mod x by x. So if I put 0, it has been given the priority as 0 should be equal to 0. Okay. If I put more than 0, say if I put 100 by mod 100, I get 1. 200 by mod 200, 1. So all the values greater than 0, I'll get it as 1. This will come here. All the values less than 0 is minus 1. So all the values less than 0 is coming to minus 1 here. This particular figure is the graph of signum function. Domain is real numbers and the range is minus 1, 0 and 1, and it is defined in this way. Okay. Then the second function is greatest integer function. Greatest integer function says, this is greatest integer function. Do remember my words. It says I am less than or equal to my nearest integer. I am less than equal to my nearest integer. Means what? If I find the greatest integer of 1.2, I have to make it less than this number but integer. So it is 1. 2.9. What? You are saying 2, no? I understood. That's 2. Say 1.56. Greatest integer. Saying 2. No, it's 1. Correct. Okay, in this way. But what about minus 1.56? Negative 1.56. Minus 1 or minus 2. In the negative numbers, I have to make it less. So I'll go for minus 2. Okay. So the graph of this greatest integer function will be, it is stepwise graph. Okay. Anything which is less than 0 becomes minus 1. Less than 0 becomes minus 1. Minus 1 should become in y-axis. Okay, wait. Okay. Anything which is less than 1 becomes 0. Anything which is less than 2 becomes minus 1. 2 becomes 1. Anything which is less than 3 becomes 2. Okay. In this way, it will continue. Okay, it is taking the value. Say anything which is less than -1, it is becoming -2, -2 becoming -3. So stepwise you can step, these are the stairs. Okay, less than 0, I'll make it oval. So these are the stairs. So you can understand the graph of greatest integer function. Our our concentration is between 0 and 1. Okay, the behavior of the signum function and the greatest integer function we have already seen. Let us find first fog. Okay, so what I do is I will utilize this space. Okay, the one where I have written the numbers. Where is the thing? Yes, it's here. So what I will do is I'll utilize this space. Fine, let's make it small. Okay, okay, now it is equal to 1. So my value, when it is equal to 1, when it is 1, I'll get 1 only. So it coincides for 1. But what if it is in the interval 0 less than x less than 1? I'm talking about 0 to 1, open interval, not 1, because in 1 they are coinciding in between, because the question is asking from 0 to 1. So FOG, FOG, FOG of x, let us think that x belongs to 0 to 1. It is f of g of x. What is my g of x? G of x is greatest integer x. Greatest integer x, f of greatest integer x. And my greatest integer is between 0 to 1. 0 to 1 will give me 0, and f of 0. Oh, sorry, I cannot use this bracket now. What is f of 0? F of 0 is 0, because f of 0 is 0. And what is f? F is a function, signum function. For 0, I am getting 0. Okay. GOF. GOF. GOF is GOF of x. G of, what is f of x? F of x is greatest signum function. Yes, signum function between 0 to 1. 0 to 1 becomes 1, isn't it? And what is g? G is a greatest integer function. Greatest integer function, let me write in bracket first, my dear. Sorry. G of 1 means greatest integer 1. I am getting it as 1. FOG is giving me 0, GOF is giving me 1. So I will say, I will conclude F and G do not coincide. COINCID. Why it do not coincide between 0 and 1? Because FOG is giving me 0 and GOF is giving me 1. And the properties of signum function and the greatest integer function, this is f of x equals to greatest integer x. Okay, these two are been shown. The domain for this is, domain is R. Do remember every time. And the range is what? Natural numbers. Oh no, integers. Z, because range is always integer. And you know, this function, which is greatest integer function, it is also said in a different way. I'll just write here. Greatest integer says that regarding the continuity, that is how the graph is, I am discontinuous at every integer point. These concepts will definitely help you in long run. Okay, so this was the question, very important one. 18, miscellaneous. Now to conclude, I have a last question for you people. So To conclude the chapter, I want to teach you one more question, which is there in NCRT. The question is, I think it is there in the example. Okay, the question is, consider this is our question number 2 for the video. Consider the function f is such that it is from 0 to pi by 2. Okay, close bracket, and it is mapped to real numbers, and the function is f of x is sin x. You can see page number 29, example number 51. Okay, and g is a function, g is also a function from 0 to pi by 2, and it is also mapped to r, and the function is cos x. Show that f and g are 1 1. Show f and g are 1 1 function, but f plus g is not 1 1. F plus g is not 1 1. Now what I am going to do is, I am going to first of all I will prove that fx and gx are 1 1 using graph, okay, of sine function and cos function from 0 to pi by 2. I am writing sine x graph. Okay, fx is sine x. Is it fx is sine x? Yes. Sine 0 0, sine 30 is half, which is 0.5. 45 is 1 by root 2, which comes to 0.6 something. 60 0.8, and sine 90 is 1. So the graph of 0 to 1, 90 degree, and this is 1. The graph will go this way. Okay, and for cos x, g of x is cos x, and the graph cos 0 is 1, and cos 90 is 0. So it will come this way. Now you can see, as I had discussed in my previous class, for every input from 0 to pi by 2, there is a unique output. If I draw parallel lines, it will intersect the curve at only one point. So f is 1 1. F is 1 1. You can just show that it intersects the curve at only one point throughout 0 to pi by 2. So it is 1 1. Again here also, if I draw the graph like this and draw the parallel lines, it will intersect at only one point. G is 1 1. Instead of doing f x1 equals to x2 and f of x1 equals to f of x2, this is an easier method to show. Now I need to check whether f plus g is not 1 1. If I have to prove not 1 1, I have to give example. So what I will do is, f plus g gives me sin x plus cos x. Now the case is 0 to pi by 2. Think of f plus g 0 degree. Okay, what is sin 0? 0. What is cos 0? 1. I'm getting as 1. 45 will be 1 by root 2, 1 by root 2. I'm not getting. If I take 90, f plus g pi by 2, what do I get? Sin 90 is 1 and cos 90 is 0. This 1. So you can understand that there are two different inputs. I get the same output, many to 1. So it is not 1 1. It is many 1 function. So students, you have to solve the questions of the NCRT exercise 1.1, 1.2, 1.3, and doubts are being taken care of. I'll be mailing you the answers which you are sending by correcting it. And one more thing, please study continuously. Okay, every day, 1 hour for mathematics. Fine. Stay home, stay safe. Thank you.